ParallelCluster is built on CloudFormation. What's really new is that now we've added external support for CloudFormation to ParallelClusters. So now you can create...
You can use CloudFormation to create a tool that generates more CloudFormation.
Absolutely.
That generates a cluster. This is where Leonardo DiCaprio is meant to pop out and like feed his drugs or something. Okay.
Just kind of waiting for the architecture to start bending here.
ParallelCluster 3.6 came with a bunch of new features, but the most important one for us today is CloudFormation support. As you'll hear from Matt and Charlie in today's Tech Short, that means we can all start sharing our favorite recipes for building clusters, and that really shortens the path between having an idea and implementing it. It also means you're creating self-documenting infrastructure because you write the documentation, the CloudFormation template, first, and then you use that documentation to create your clusters. So Matt and Charlie are going to do a great job of explaining how all this works and why it matters, so keep watching and I hope you learn a lot from them. But when you're done, you can click over to this blog post that Matt wrote, which goes into a lot of details and walks you through a specific example. I'll leave a link in the show notes.
So we talk a lot about infrastructure as code. We should probably talk a little bit about, and just rewind things and talk about what is infrastructure as code, kind of level the playing field a little bit, make sure everybody understands where we are. I mean, I think that will help it so that you can kind of understand why this is so impactful. The idea is, you know, you're sitting here, you're thinking, you're cogitating, you're designing this infrastructure. You write it out as code, you check it into source code management, and then you have some connection between your source code management and an API or a management server that pulls the code in from that repository, that source of truth, and then it manages, updates the resources out in the cloud layer. You don't put your hands directly on the cloud deployed resources. If you need to tweak it, you change the code.
Not the cluster.
That's right.
Or the yeah, right, exactly. And that's the difference here. You're getting a recipe, and it's a recipe you tweak, it's a recipe you refer to. The recipe is the thing that goes into GitHub as your manageable asset that's version controlled.
That's right.
The infrastructure is not being version controlled, but it effectively is because you're always building that infrastructure off this recipe. You could burn your entire house to the ground and reconstruct the whole thing from the recipe, and you get bit for bit what you started with. I mean, for people, the uninitiated, CloudFormation is like this declarative language where you say, dear cloud, dear AWS, I want these things.
Yeah, we call that the state of the world. You say, this is what we want the state of the world to be.
Right.
And the underlying CloudFormation knows, based off the references, what order things need to be created in. So instead of having an imperative, create this first, and when that's done being created, then create this next thing, you just describe all the things that need to be created in their relationships, and the order that they get created is defined by their dependencies. And that's all CloudFormation's really responsibility to figure out. So you just state what you want, it figures out how to create that and the order to create those in, and to connect the references between these other resources.
Right, I get it. And so to connect the dots here, you will have a CloudFormation, we'll have a portion of that big CloudFormation template that refers to ParallelCluster that says, I want this cluster laid out in this fashion.
Yep, that's a resource within the template.
Right.
In the template.
But it may, that cluster needs, say, a Lustre file system. Now, CloudFormation, create me a Lustre file system. I need this persistent Lustre file system over here. I may need a Scratch one over here. I may need FSX for OpenZFS.
Sure.
It's a separate thing for home directories or some other user data.
Yep.
And then you can stitch all of that up together and actually combine how all those things are referenced to each other and the relationships between each other inside the CloudFormation template, and then just let it launch, right? If you've got long-term resources like storage, you're going to use a CloudFormation template to spin up some storage as well as your clusters, and it's going to connect with your Active Directory server and all these other bits and pieces going on. You don't necessarily want to delete all of the storage when your when your stack comes down because your cluster's done with.
Every resource has a retain on delete property. You can set it, and that will indeed make it persistent.
Right. So then your cluster isn't necessarily persistent, but the storage is more to the point the data is at that point, and that makes a whole lot of sense.
So a CloudFormation file, or is really called a template, and that makes sense if you think about what it does. you use a CloudFormation template to deploy a stack, and a stack is a collection of resources. Each template has at least a list of resources, and there could just be one resource. But they also usually have things like parameters. The parameters you use to tweak the configuration of the various resources. They can also have outputs. So the outputs are properties of the resources, and you define those. So let's say you have a resource that defines like a simple queue service queue, or defines a security group. You can put in your outputs the distinct ID for that, and that way, in other consumers that use your CloudFormation, can basically, instead of having to go and dig through all of the resources and everything, they can just go and say, hey, yes, here's the name of the security group. Here's the name of the queue. Probably the coolest thing about CloudFormation and just generally this design is that you can compose them together. And what I mean by that is, so when you have your listing of resources, so most resources usually have like a specific type. They're an S3 bucket, they're an EC2 instance, they're a file system or an EBS volume, but they can also be just links to another entire stack.
Right.
And what's really cool, so you can have, you
Nested.
can compose, you could do nesting, and that is, I mean, that's how ParallelCluster is implemented under the hood, but then also this is a way where you can logically separate your pieces of infrastructure. And so, for instance, if you wanted to have a template that stood up a managed Active Directory and stood up a database server for Slurm accounting,
Right.
you would basically import those as nested stacks, and then you wire them all together by connecting parameters and properties and outputs together.
A really cool thing that I'm excited to see coming out of this feature is seeing the experts who can describe a certain cluster configuration as an environment and then hand that template over to be customized, essentially creating some guardrails here where when you instantiate that template, you're really instantiating this entire environment with all of the resources, and that's going to enable certain people, the staff within a large research organization, to be able to define the setup of a cluster, maybe specifying the users and the databases that they want to connect to, and then provide that to the individual researchers to create their own clusters that reference those external resources, but maybe are customized to the needs of that individual researcher.
And when we say referencing external resources, we could mean it could be just something as simple as having ParallelCluster use the Active Directory server inside the organization to do authentication, so that when your cluster spins up, you use your own password to log in. And it looks like home. Right. And that's just simple customization, things like that.
And your storage as well, right? Those are the two common ones that we're really seeing people want to. Exactly.
My password is like it usually is when I check my email or I log into the corporate intranet. It's just the same stuff. And it allows us to embed that. And I think this also puts us one step closer. In fact, it delivers us to the place where we could actually say to customers, here is the recipe for building a really optimized parallel cluster for running small molecule molecular dynamics simulations with GROMACS. Here's the thing that we think is an opinionated way of doing that. Here's the one-click launch button, and it could literally be that, right?
Yeah, exactly. I mean, this is the other beauty of it. It's integrating with other AWS tools, right? So now you no longer need to necessarily use the ParallelCluster CLI. You can use the AWS CLI. You can use the AWS console. You can upload this to S3 and create a one-click or quick create template that allows you to create everything over the web. You can use the API. All of your standard tools that you're using to interact with AWS services, you can use those, and you have a CloudFormation template that has a ParallelCluster configuration embedded in it, and you're leveraging those tools to create and manage your cluster.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.